So in our previous video, we looked at the definition of a function. And we saw that the definition tells us that within a function, every input maps exactly to one output. So now we're going to look at some graphs and we're going to ask, is it a function based on what we see in the graph? And we have something called the vertical line test. And the vertical line test will tell us whether or not we have a function as well. So, functions must pass the vertical line test. So, why? So, let's take a look at this blue graph. And I already have an XY chart started. So, let's go to the graph and let's find the function's values when x equals -3. So, when x equals -3, y equals -2. And when x equals -1, y equals +1. When x equals 1, y equals 4. X equals 4, y equals 5. Now, I will add right here that when we evaluated the function at x equals 3, it only mapped to one and only one point. So the one input took us to exactly one output. The same thing at -1. -1 only maps to +1. And of course, we can see the graph of this. So this one is pretty obvious. And the vertical line test says this: does or will a vertical line drawn at any point pass through the graph more than once? So if I come along and I start drawing vertical lines at any point through this graph, there's a vertical line at x equals -5. It touches the graph only once. Here's a vertical line at x equals 0. It only passes the graph once. Here's a vertical line, touches it once, touches it once, touches it once. So this particular graph is a function because it does pass the vertical line test. We can also see in the brief picture of what I'm showing you here with the domain that none of the x input values repeat themselves, therefore this indeed is a function. So let's look at the graph that is going to be at the bottom. Keeping this question in mind, does or will a vertical line drawn at any point pass through the graph more than once? So here's a g function. This g function says square the x value, then add 1. And I don't have any x values input here. We're going to come up with some on our own. And lots of people always ask, well, how do you know what values to plug in for x? Well, in this case, let's just use some that will actually physically fit on the graph. Now, a good one to always start with is let x be 0. When x equals 0, what is the evaluation of the g function? Well, that will be 0 squared plus 1, and 0 squared plus 1 is 0 plus 1, which of course is 1. Let x be +1. So g of +1 will be 1 squared plus 1. That's 1 plus 1. That is 2. Let's plug in a negative value. How about -1? When we plug in -1, we get -1 squared. Again, note the use of parentheses here. They're always a good option. Plus 1. So -1 squared is 1, and 1 plus 1 is 2. So is it okay to have repetitive y values? Is that still going to allow our graph to pass the vertical line test? We'll see in just a moment. Let's plug in about 2 and -2. So if we plug in 2, that'll be 2 squared plus 1. That's 4 plus 1. That is 5. We plug in -2. We again get 4 plus 1, and that is equal to 5. So here's what this is going to look like on the graph. Over 0, up 1, over 1, up 2, back 1, up 2, over 2, up 5, back 2, up 5. I'm hoping that most everybody knows that this indeed is a parabola, and a parabola is a quadratic function. So it's a parabola that has a vertical opening, and will it pass the vertical line test? Well, let's try it here. So it gets close to being vertical here, but it's not vertical. Therefore, it'll pass the vertical line test there. It will pass the vertical line test there, and there, and there, and there. So yes, Does or will a vertical line drawn at any point pass through the graph more than once? If the answer is no, then you do indeed have a function. So back to my question. Is it possible to have repetitive y values and still be a function? Yes, but you simply cannot have repetitive x values. Why? Because the definition of a function says that each input maps exactly to one distinct output. So next in the video, we're going to be looking at some graphs and determining whether or not we have a function using the vertical line test. So here's a graph. This is the graph of an absolute value function, and an absolute value function does indeed pass the vertical line test. So at any point when I draw a vertical line, how many times does it touch the graph? Only once. Then yes, it is indeed a function. So here's two more to look at. The green graph, of course, is a horizontal line. And I want to take just a moment and let you see the XY chart of this green horizontal line. So the green line. So I've got a few points already marked off here. So this is negative 5, 6, or excuse me, negative 6, 5. This is negative 2, 5. We can even put one more on the y-axis. That would be 0, 5. That would be 2, 5. That would be 6, 5. So once again, will this green line pass the vertical line test? Yes, the green line will pass the vertical line test. And no, even though we have repetitive y values, that's okay, as long as we have distinct input values. Negative 6 only maps to 5. Negative 2 only maps to 5. So yes, a horizontal line is a function. Now, let's take a look at the blue line, the vertical line. Can a vertical line pass the vertical line test? No. Also look at its XY chart. So when we start plotting these points, negative 3 goes to 0. Negative 3 also goes to negative 3. Negative 3 also goes to negative 5. Negative 3 also goes to negative 7. So what we have here is we only have one input. And that one input maps to multiple outputs. It's like going to the vending machine and hitting the same button and then getting different bags of chips or candy bars every time you hit the same button. That's not a function. And also, like I said earlier, can a vertical line pass the vertical line test? No, because it's going to touch it at infinitely many points. Now, we've got two more quickly here. Will it pass the vertical line test? Yes. 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 So even though we've got some roller coaster activity here, yes, this is a function. One last one, which is almost the inverse of the one we just saw. Is it a function? Nope. Because we're hitting there, there, there 3 times as we pass through. And again here, we have multiple y-intercepts. And even though we will pass the vertical line test all the way over here, remember, it's got to be at any given point can we draw a vertical line and it only touched the graph once. So even though it might pass here, it doesn't pass here, and here, here, many, many, many more opportunities where it does not pass. So no, not a function. So last thing in this video is identifying the domain and range of functions. So I like to do this with the help of some handy dandy index cards, which of course are some of my favorite things. And what we're going to do is we're going to find domain and range. First of all, we're going to be doing it in interval notation. And we're just going to call domain capital D and range capital R. So with my handy dandy index cards, I am going to try to close this thing in from the left and the right. Now, can I close it in if it has an arrow? No. On the left? No. On the right? No. So it is going to the left forever and it's going to the right forever. That means it has a domain that is all real numbers. And the easiest way to show all real numbers is with negative infinity to positive infinity. And once again, when I'm looking at the range is read from the bottom to the top. But once again, arrows. Arrows going down, arrows going up. The range is also all real numbers. Of course, this is a linear function. This is just a function that is a line. It would have an equation of y equals 1, 2, 3, 1, 2, 3, 4 of 3/4 x minus 3. Very clear to see that there are no restrictions on what you can put in for x as an independent variable. And then the dependent variable y will also have no restrictions as well. That's why the domain is all real numbers and the range is all real numbers. To the bottom. The function on the bottom is an absolute value function. So we will see these later in this chapter. So looking at the left and the right, is there a leftmost point? No, because of the arrow. Same thing on the right. Anytime you've got arrows and they're going to the left and the right, you really can't hem this in. So the domain, again, is all real numbers. Remember, domain is read from the left to the right. Now, the range is different because it's going down forever, which means there's going to be nothing on the bottom, but there is an uppermost point. We have an absolute maximum value. And that absolute maximum value is going to be the top of the range. Range is read from the bottom to the top, just like the number line, bottom to top. So where does the range start? The range has no bottom here, so it starts at negative infinity. But it goes up to and includes 7. And that 7 will be in brackets because that circle is closed on the top of the graph because the point 0.07 is the absolute max value. Domain all real numbers, range, bottom to top, negative infinity up to and including 7. Now, next graph, this is the graph of a square root function. And if we try to find a left side, well, we've got one. The leftmost value is x equals 2. It is solid, therefore it is included. So my domain starts at 2 and then goes to the right forever. So the domain goes from positive 2 to positive infinity. The range, once again, this has not an absolute max, but an absolute minimum value. And what's nice about using an index card is it's clearly showing you what that minimum value is. Remember, a max or a min is all relative to y, all relative to the y-axis. So our range here being read from the bottom up to the top, it starts at exactly 3, and then this goes up forever. So the range goes from 3 to positive infinity. On the bottom of our sheet here, this is a piecewise function. Piecewise functions have all sorts of applications in business fields, manufacturing, lots of applications in science. This is just a nice little graph, and we're going to find the domain. Remember, the domain starts on the left, so we're looking for an arrow on the left. There isn't one, which means that our domain is starting at -7. and it's closed, so I will put that in brackets. -7. If we keep moving to the left, there are no gaps and no overs, no repeats. Remember, that open circle means it's not included, so we keep moving, we go all the way to the arrow. So the domain is from -7 to positive infinity. The range. Start at the bottom, the range. We have an absolute minimum value, and that absolute minimum value, remember the range has to do with the y-axis. Our absolute minimum value is inclusive of -8, up, 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 up. We stop at 3 because there's a gap here. So we go from -8 to 3 inclusively. And then anytime that we have a gap in the domain or the range, we're going to show that with the union sign. Remember, the union sign means or. So or. Then we pick it back up here, and this function is a horizontal line, and it is at y equals 1. So it's just a single value, 1, because it's horizontal. Then we have another gap, up, up, up. It starts at 4, but please notice that that circle is open. So we're going to finish it off here with a parenthesis at 4, and then to the arrow to positive infinity. Squeeze that little infinity right in there. So this piecewise function has a very unique range. It starts at -8, goes to 3. Jumps up to y equals 1, the horizontal line. All the y values are equal to 1. Another break, and then it starts at 4, but not including it, and then goes up forever. So 1, 2, 3 pieces, 1, 2, 3 intervals of the range. That's domain and range.